Look at this box. This thing is solid. Hey guys, welcome back. So I've been gone for a while. I was in Thailand for 3 weeks and it was very hot and very humid. So if you're ever going to go there, don't go there in May or April. That's the hot season. So anyway, this is like going to be, I guess, the start of a series where I'm building a bunch of batteries using these 48 volt DIY battery kits. They're essentially these boxes which you can put your cells in, and they come with a BMS. This particular one has a Seplos BMS. Let's take a look. So here's the battery. I've had it built for about a week now and I've been testing it. It's a 15 kilowatt hour, and the box itself is pretty nice. We're charging it up right now, top balancing. But let's get started. Okay, let's see what we got in the box, literally. Number one is our cell padding, or cell spacers. Number two will be your PCB board and bus bars and your balance leads. Number 3, 4, 5, and 6, I'm guessing. No, number 3. Alright, these numbers are off. We got our bus bars, our battery terminals. Looks like a fuse. And some sticky pad and hardware. And 4 is our BMS, 48 volt, 16S, 200 amp. And we got our battery cables. Okay, so the first thing we need to do is remove the front cover. Next, we want to remove the top bracket. These two brackets hold the PCB boards. I like to put the screws back where I found them. Now we can remove the front pressure plate. There'll be 2 pre-installed screws that can be thrown away or kept for later use. Next, you'll need bag number 1 with the epoxy board and foam inserts. The 4 rectangular pieces will go on the back and the front of the box. For now, we'll just install the back ones. Next, the bottom and side epoxy board. There are 2 sizes. There's a smaller size, 2 pieces, and there's a larger size for the sides, 4 pieces. Just place and stick. Next, we'll install the 4 side pieces. This stuff really sticks good. Be sure to make sure you got it exactly where you want it before you stick it. Now the epoxy board is installed. So this is probably the most important part of doing this entire build, is making sure your batteries are in the proper order and the proper orientation. Because when you connect the BMS, this being the front of the battery, your main positive will be here and your main negative will be here. So you can verify that you have the batteries in the proper orientation if you take the front plate and just put it on like that with the positive on the right side, just like that. The positive will be here, and then the BMS sits right in here, and the BMS connecting leads will end up right about here for the main positive and right about here for the main negative. I'm arranging the cells in order of capacity from largest to smallest capacity. The reason for this is to hopefully add more natural balance to the pack. I will explain this idea shortly. This is essentially the point of no return, because now this is weighing about 200 pounds. I hope I did it right. So I got the bus bars temporarily hooked up. We're going to connect up the charger and see if we can find if the current is flowing higher on this side or if it's flowing higher on this side, or if it doesn't make a difference at all. So I got the battery charger connected, and it's charging the battery with 10 amps. So first we'll probe here and see what we get. 9.71. 9.8. We'll just say 9.8. And next we'll probe over here on the negative side. And 10.4. So it is higher. It's interesting. Alright, so I've completely switched the cells, completely flip-flopped them. So we got the smallest capacity cell on the positive side, we'll call that position 1. And we got the largest capacity cell on the negative side, and we'll call that position 16. And there is a consistency. We had more current on the negative side than we had on the positive side. Now this could be a complete nothing burger, but take a look. 9.75. Remember, this is the smallest capacity cell. I'll go over to the largest capacity cell over here. And look at that, 10.24. So we got more current going into our highest capacity cell, 970 watt hours, or 298 amp hours, versus the smallest cell, and 296 for the small one, 962 watt hours, 9.75. This could spark a huge topic of debate because which direction the current flows, right? But even in my last video, I did a video long ago about testing matched cells and mismatched cells, and you can see it here. And the matched set, you would assume it always would be in position 1 or position or the last position, first or last. That would be the first cell to go high, go into over voltage protection. But that wasn't the case. It was the cell number 2 and 3. It was in the middle in the matched pack. But on the mismatched pack, it was actually cell number 4, but number 4 was actually the lowest capacity cell. So a little bit of consistency there, but I don't know if I'm buying it. So the idea behind organizing your cells like this is, if you capacity test your cells, there's going to be some deviation, right? It could be as much as 4 amp hours between the highest capacity cell and the lowest capacity cell. So if in fact it is true that the current is greater on one side, let's say it comes in on the negative side, and by the time it gets to the end of the pack, so cell number 1 will have the most current, and cell 16 will have the least amount of current. That suggests that you want to put the smallest capacity cell last, because if you put the smallest capacity cell first with the greatest amount of current, that cell is going to trigger OBP sooner, and it's going to limit the entire pack, thus making your BMS work harder. So by doing this, it's like a natural balance, and then your BMS is just icing on the cake. Just remember, you do not have to do this. I'm completely OCD, and I'm trying to build the best pack possible. Your BMS, this is the job of the BMS, so you can just buy the cells, put them in the box, and let it charge. But for this build, I think I'm going to go with this. I like the way this is working, and theory or no theory, I like it, and we're going to stick with it. Okay, so the next step is putting in our insulating pads. This will do a couple things. It'll give a little bit of cushion when the cells expand and contract when they're charging and discharging. And it'll also help to give the necessary compression to our cells. These will go in between the cells. Now these have a sticky back, but I'm not going to take the sticky off because I don't want that sticky junk on my cells. If I ever have to take my cells out, I don't want to have to peel the stuff off my cells. So we're just going to be putting them right inside just like this, no sticky. And then after we do that, we're going to put these on the front of our pressure plate, and then we can install our pressure plate. You can see here that I organized the cells from greatest capacity to least capacity, greatest capacity being in position 1 on the negative side, and the lowest capacity cell being on position 16 on the positive side. Now we can put on our pressure plate. So when you put the pressure plate on, we're going to have to take the sticky off and then try to get it in here without getting hung up. But This is the problem. You do not want to cover these holes. This is where the bolts go. So it's got to go just like this, just about like that. All the way over to the right, not all the way over, but a little bit over, and a little bit down on the bottom. So I think what we can do, put the plate there, and put this kind of in position like this against the cell with the sticky surface facing towards the plate. See if we can get, well, let's just do one at a time. We just need to stick it. We'll just put that just like that. Check your holes, make sure you're not covering the holes. This plastic should fit just inside of this plastic, so I'm going to take the 2 screws that came pre-installed with the pressure plate. You're not going to use these, by the way. There's other screws that you'll use, and I'm going to position the plate so that it's in place, because it'll be a little bit higher when the screws are in place before we stick the pad. Okay, so the plate's in place. Put our insulation against the plate. Now the insulation will be just below, a couple millimeters below the cell, below the top of the surface of the cell. Same with this side. Plus it'll ensure, by doing that, by putting the screw, especially in the middle, it'll ensure that you do not block the screw holes with these insulating sheets. Alright, so now we should have a perfect alignment of these insulating sheets. So now we can stick it. And these really stick, so make sure you get it right the first time. Because once you stick it down, man, these things do not come off. So looking at the back, you have a little bit, about 1/8 of an inch on the bottom, about 1/2 an inch on the tops, and again 1/8 of an inch on either side. These holes should not be blocked. That's how it goes, just like that. So now we can put our plate in for reals. You can actually use this bag. It's the 7 pieces, 22 screw M6 25. There's 7 of these. So we're just going to get this started here. Now that we have that gap, we're going to try to fill up that gap with our pads. So I need to back this screw out a little bit so we can get some movement in there. We got to keep pressure on both sides. Okay. All right. Now we can take our 10 millimeter. Don't go too crazy. Okay. See, I lost my 10. Now it's time to install the bus bars. The kit will come with the bus bars here. It'll be bag number 2. Alright, so this is the bus bar that comes with the box. It's aluminum, so not really thrilled about that. But I also have these bus bars which come with the cells. Also, I think are aluminum, because they're not, but they have this insulation on them where these do not. There's this sticker on here which you're supposed to take off. So I think I'd rather have the insulated ones. And I got these ones. These are really nice. These are flexible bus bars, see? But these cost $7 each. See that? So these are actually really nice, but I only have a few of these. So what I'm going to do, I think I'm not going to use the one that came with the box. I'm going to use the ones that come with the cells because they have the insulation, and I'm going to combine these, and I'm going to put these in some certain special spots along the pack. The other thing, these nuts, I dropped them inside this channel twice. And I dropped one back here. So you might want to take some electrical tape and cover up these holes, because if you drop one down there, it has to go in sideways, and then it lands flat. So when you try to take it out, you're going to be pulling it out this way and it won't come out. You have to literally grab it and pull it through that little hole. It's very difficult. You'll have to disassemble your cells just to get in there. It's very difficult. So tape this up so you do not drop any nuts in there. If you do, it's gone. Just forget it. You're done. Tape this one up, tape this side up, and tape this side up. You will not have any bus bar on this. And the next one will go here. Just keep on going down the line. That completes one side of the battery. Now I'm going to skip this for now because this will be the connecting piece between both 24 volt packs. Once we connect that, that'll give us our 50 or 52 volts approximately. We'll put one here, and then we'll have one here, one here, one here, one here, one here, and the last one here. We're going to figure out where we want to put our special links. This will give us flexibility in the pack, because once these are rigid bus bars, and these studs are rigid, right? They're rigid. So there's two applications you might want to use these. In a vehicle, when the battery's bouncing around everywhere, if you don't have your cells compressed, there'll be stress on the studs, right? But these studs can't move. So if they're bound by the bus bar, the stressor will be on the studs. You'll be basically pushing back and forth on the studs, and that can weaken the studs over time. That's why these are great, but they're expensive. When they charge and discharge, the cells will expand and contract very slightly. So over time, that can also put stress on the cells. So we're going to put these in key areas in the pack to help alleviate any stress within the pack. I really wish I could just use these only, but yeah, at $7 a pop, that's yeah, you're looking at $100 in bus bars if you do that. So hey, if you got the money, these are the best you can buy. These are absolutely great. They're basically layers of copper squished together. It's really awesome. So you know one's going over here for sure. We'll leave that there for now. I got to think about this. 2 cells and then a flexi. This pattern here, and then a flexi over here on the opposite side. So I don't know, there's probably a million ways I can do this. What do you guys think? Is there a better way I can organize these? Before we put the nuts down, we want to do one thing. Okay, we want to verify again that we have these packs assembled correctly. So each pack should give us 24 volts at least. So what we want to do, just with the bus bars lying on top of the studs, not bolted down, we want to test the voltage of each side of the battery. So between here, our main positive, and the end of cell number 8, hope you can see that, 26.29. Good. Main negative here, and main positive here, we should get 26 volts again. Great. Install our connecting bus bar. That'll give us our 52 volts. And from our main positive and main negative over here, we should get 52 volts. Great, that means all the cells are connected properly. We're going to use our washers here, 32 pieces, plus 2, and we're going to place the washers on top of the studs. Now it's time to install our top brackets. They'll go right here. You're going to take your insulating pad, sticky pad, and that's going to go underneath the bracket, just like that. And it'll stick to the underside of the bracket. These vents should be clear of these holes. That's the purpose of these holes, is to let the vents have room to vent in case they need to. Yeah, good enough. I'm sticking with that. Pun intended. So what I did, I took a razor blade and I cut the excess along the sides off. So when we put it down, you don't have any sticking up like that. So kind of made a little mistake maybe. When I went to put the bar on, I realized it wasn't exactly lining up over the top of the vents. So it seemed like I needed more space in between the cells to get them to line up more. So I realized I had 2 extra pieces of foam. And I didn't put any foam on the back of the cells back here. So I'm going to try to loosen up the pressure plate and push the cells forward and try to slide these foams in on the back side. Ridiculous. You know what? I lost that one too. Damn it. Now we can apply our pressure plate. Next, you're going to need your bag of 8 pieces plus 2 pieces, M5 times 8 screws. I'm going to cross tighten them. If you have a magnetic screwdriver, definitely use it. Okay, so you have 2 extra. Save them for later. Okay, now it is time for the PCBs. Now this is important. There's 2 PCBs, obviously. There's a DKA and DKB. Right there, P1. That stands for Pack 1. And DKA, I don't know what DKA means. So that's going to go on this side. And this one will say P2 or Pack 2. And it'll say DKB. And the connectors go towards the front of the battery. That'll go on this side. You're going to need this bag. 12 pieces plus 2 screws, M4 times 6. PCB and jelly time, PCB and jelly time. Who remembers that? I'm such a dork. Okay, both PCBs are nailed down, and I want to show you something because this is very important. You'll notice these wires up here, they're both red, but this is the negative terminal. It says minus. Same with back here. You have the 2 red wires, but this says negative, and this is the negative terminal. Why they made these wires red is beyond me, but they really should be black because it causes confusion. However, this is the way they're connected. Here, let's take a closer look. They're probably just lazy and that's why they did that, but the BMS needs 48 volts to operate, and that's how the BMS gets its power. It gets its power from the main positive here, right? And it gets its negative power from the main negative here. So between here and here, we're going to have 48 volts nominal. So that's why you have your plus and your minus. So every cell in between is going to get a positive balance lead on the positive terminal. So here, 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 and here. Likewise over here, 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 and here. For that, you're going to need this bag, 30. And if I got these mixed up, and I earlier said this was cell number 1, I'm sorry, because until now do I understand that this is cell 1 because this is DKA pack 1, so this has to be cell 1. And cell 8, cell 9, and cell 16. Be sure that you have your washers down, because the balance lead wires will go on top of the washers. Okay, alright, so these guys here, you'll notice this little bulge right here. These are temperature sensors. There's 4 of them. There's one here, one over here, and one over here. And that'll be coming out of the center of the PCB. Center, 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 center. All the temperature sensors go on the negative terminals of the battery. Okay, but they go on specific batteries, so they have to go, or cells. This is where they go. On DKA, the first temp sensor go on cell number 2, the negative terminal. The one nearest the rear of the battery will go on cell number, this temperature sensor on DKB will go on cell number 11, negative terminal. And the temp sensor over here, closest to the front, will go on cell number 15. Top right, bottom right, and bottom left. I'm just leaving this, everything else should be buttoned up right now except for this right here and the front. We don't want to connect these right now. Okay, so I missed this one here. It's because it's a negative terminal. All the negatives basically. Put the nuts on all the negatives. Okay. Alright, so at this point we'll have 2 nuts for there. You have the bus bar that's going to go there with the 2 washers, right? And the 2 nuts. So we're going to keep that for later. The reason I'm doing that is for safety, because right now we have basically 2 24-volt packs, and there's no need to connect that up right now, because if I did, it'll give you 54 or 52 volts. So that's the only reason. The instructions don't really say yes or no to do that, but that's the way I'm doing it. Okay, it's torque wrench time. So welded studs for these cells, they recommend 8 Newton meters, or anywhere from 70 to 80 inch-pounds. So please check with your cell manufacturer the type of studs you have to determine how much torque will be required. Some manufacturers, Chinese manufacturers, will use Newton meters. So you're going to convert Newton meters to inch-pounds if you're using a torque wrench. Good. Okay, that completes the first half of the build. Let's move on to the second half. I ended up using Kapton tape, high temp Kapton tape, for the center right here. It looks nice. Okay, so after putting the video together, I realized it's going to be almost an hour long. So we're going to split the build video up in 2 videos. The first video will be, well, what you just saw. And the next video will go ahead and finish up by installing the BMS into the battery. And then third video will be actually top balancing. Alright, see you on the next one.